Hello. I'm trying not to trip over all of my things. I'm moving soon, so I am surrounded by boxes of things that belong to me. I would like to introduce myself. My name is Michelle, and this is a math video. We're going to talk about exponential and logarithmic functions and their derivatives. In particular, we're going to do a couple of trickier ones. So if you're very new to the subject of exponential or logarithmic differentiation, then we should look at maybe some simpler examples first. Given that you're feeling okay with the simpler stuff, we're going to take the derivative of the function y equals log base 4 of 6 to the e to the x times log base 7 of x. This whole thing is upstairs an exponent to the 6th, but we're going to go in stages. The first stage is we're going to differentiate y equals x times 6 raised to the x squared, and then we're going to differentiate y equals log base 4 of x cubed minus 2 to give us a feeling and a reminder about exponential derivatives and then about logarithmic derivatives, and then finally we can do this one. So let's start with number 1. I don't think I should erase them though, because I'm worried that I'm going to forget what they are. So let's start with 1. All right, this here is an x and it's times a 6 to the something. So we have a product of two different functions, the x and the exponential. So we're going to use the product rule. We're going to take the derivative of this part times this part left alone plus this part left alone times the derivative of this part. So let's do it. So y prime equals the derivative of x is just 1, and we leave the 6 to the x squared all by itself. And then we add to that just leaving the x alone and taking the derivative of 6 to the x squared. So there are a couple of things we need to remember when we take this derivative. First, just like e to the x, the stage that you start with is you write 6 to the x squared again. The exponential functions have this trend that their rate of change is very similar to themselves. That's why, for example, e to the x has the derivative e to the x. So 6 to the x squared's derivative starts out as 6 to the x squared. Then remember, because it's base 6, we have to add a ln 6, kind of a little fudge factor there. And you're done that part. Now you just have to worry about the derivative of what's called the inside function, or the function stuck upstairs. That is x squared. So the derivative of that gets multiplied by your whole thing, and now you have a 2x to add to this part of the product rule. And that's fine. We won't even bother simplifying. We just focus on getting the derivative. So that's number 1. Number 2, we're looking at log base 4 of this argument x cubed minus 2. So when we take the derivative of log or ln, any kind of logarithmic function regardless of the base, we go 1 over the argument right away. That's the first step. So we're going to go 1 over the argument, which is x cubed minus 2, and that remains unchanged. But remember that beside the whole bottom, or denominator, you have to remember to go ln times the, or ln of, not times, ln of the base, and in this case it's 4. Now, if this happened to be a ln, otherwise known as log base e, we would maybe write times ln of e here, but it would end up being 1. In this case, this stays here because it's not 1. Finally, we have to remember that just like before, we have a chain rule where we have to take the derivative of the inside function and multiply it by what we already have. So that's going to be times the derivative of x cubed minus 2, which comes out to 3x squared minus 0. So your whole derivative looks like the 3x squared over the x cubed minus 2 times the ln 4. We won't bother simplifying, and in any event, it's really difficult to simplify because although there's an x squared in the top, there's not an x cubed in every single term in the bottom. Think about that right now if you're not sure what I mean. These are our two derivatives to start with. Now let's get to our third one, which is the nasty one, and see if we can find a victory. Also, there seems to be a problem with my whiteboard, and someone broke something downstairs as well. So, just just bear with me for a second. I require... Oh, the Kleenex works much better. Okay, well maybe I'll stop stealing office supplies from the workroom. A brush is not very helpful anyways. Alright, so now we're going to do part 3, this whole thing. So you're going to start out looking at how we have a log base 4 of some stuff and we want the derivative of that. So y prime for 3 is going to start with a 1 over. And the 1 over is going to be this argument, 6 to the e to the x times the log base 7 of x, that whole thing in the exponent. And then because it's a log base 4, don't forget, your whole denominator has to be multiplied by a ln of 4. So at this point then, we have to go times the derivative of the inside. So I'm going to say times 6e to the x times the log 7x prime. To indicate that, I kind of want to go in stages, and I took the derivative of the outside log function, and now I have to take the derivative of the inside with respect to x. So let's do that in the next line. So we have this still, so 1 over 6 to the crap, okay? And then we have to take the derivative of this. So what we'll do is we'll follow the same rule we used when we took the derivative of this bit. And we're going to start by saying it's just the same function over again to start. So that's 6 to the e to the x times the log base 7 of x. And then ln 6, because we're dealing with not an e to the stuff, but a 6 to the stuff, so ln 6. And then times the derivative of even the more inside function, which is this exponent. Remember, we did the derivative of x squared. Now we do the derivative of e to the x log 7x. So let me do that by saying that's e to the x times log base 7x prime. That has to go right here. You could do this in all one line, but it seems I'm going to take 3 just to take my time. Okay, so last but not least, we have this stuff again, which clearly I'm not writing. I'm too lazy. I didn't even dress up for this video, so you can tell. Times this, 6 to the e to the x log base 7x times the ln of 6 times the derivative of this. Well, this is a product rule, and it's made of 2 parts. The e to the x is the first function. Multiplied by it is the log base 7 of x is the second. So knowing we don't have to simplify, with reckless abandon, let's take the product rule for the derivative of this. The derivative of this part times this plus the derivative of this part times this. Starting with the derivative of this part, it's just e to the x again. So that's e to the x log base 7x for the first part. E to the x now is left alone, which is kind of funny because when we took the derivative it looked like we left it alone, but we did not. And then we have to take the derivative of a log base 7 of x. Logs start with a 1 over, so it's a 1 over x. And then don't forget that you have to go times the ln of 7, right on the bottom, multiplied by the whole argument. Because we just have an x, we really don't have to go any further with this, because the derivative of this inside is just 1. I won't even write that this time, just to illustrate that. When it's just a plain old x, you're done. So this is that derivative, and this is pretty complicated. So I would say if you were able to master these 3 in succession, and that you could do a very similar one that you made up for yourself, maybe changing this base, and maybe making this a different product rule, maybe with square roots or something, I'd say you're on your way definitely to being able to ace this subject. So good luck and good night. Looks like I'm dressed for bed.